Hello everyone. So again, welcome back to the latest lecture session. And our course is obviously dealing with the remediation of contaminated sites. So in this context, we were looking at, let's say, or summarizing, let's say, a case study or two, right? So that it will help you come to a decision whether to take the course and so on, right? So in this context, we looked at a brief example of chromium contaminated site in India, where primarily the contamination was groundwater contamination. And obviously there was limited data in that context, and then we moved on to another case study where we have, let's say, a contaminated landfill, or pardon me, a landfill that's leading to contamination of soil, groundwater and a few surface water streams, and thus there were some affected areas, right? So again, in today's session we are going to, let's say, finish understanding that particular aspect, as in with respect to remediation of that particular landfill or the issues caused due to that particular leachate from that landfill reaching the groundwater, surface water and so on, right? We are going to look at some of the remedial alternatives, and then how did they go about choosing that particular alternative and so on. And obviously during the course of our during our course we are going to look at, let's say, the technical aspects involved with understanding each of those alternatives, right? So again, let's jump back to where we are here. So obviously here we looked at this particular figure last time, and here we have two particular landfills, the major one being here, right? And this was on a hillock, and obviously as I mentioned, option that was finally chosen, or the alternative that was finally chosen, was having a ring of extraction wells, right? A ring of extraction wells pumping out the particular leachate, right? And then treating that off site. Yes, that was, I believe, the option that was chosen, but we are going to look at how the decision was made, right? So that's what we are going to obviously look at. And obviously as you can see, the extraction wells do not ring the entire perimeter of the leachate, but in a particular site, though. That obviously depends upon site characteristics and transport of the leachate and so on beneath the surface of the soil, right? So anyway, there are different aspects. So again, a quick recap, and we have been looking at different aspects here. Major aspects being hazard identification. We identify the relevant toxic compounds. We then identify the relevant pathways. We then look at how toxic is each of these compound that we identify. Let's say, is it a carcinogen, non-carcinogen, is it a toxic compound, and so on and so forth. We have relevant data here, usually reference doses, right? Reference doses or acceptable daily intake levels for non-carcinogens, and for carcinogens we have something called slope factor, right? We are going to look at these aspects in greater detail too, right? As in, why are we going to look at these in greater detail later on during the course of our semester, or pardon me, during our course here, right? That it's because, right, say, we need to understand that it's not a science, or it's not an exact science, I guess, right? Sometimes it's, I wouldn't call it an art, but it's certainly not exact science, because there are considerable uncertainties involved out there, right? Especially with trying to come up with risk characterization. So we are now going to try to put down a number that would estimate or give you an idea about, let's say, the risks that particular contaminated site poses to either your human population or to the environment or the ecologically sensitive areas out there, right? So in that context, obviously we look at carcinogenic and non-carcinogenic risk, right? And usually are these we call the toxic compounds, let's say, right? And then we obviously look at environmental risk, but environmental risk or ecological risk assessment is much more comprehensive. So during the course of our semester, we are going to limit ourselves to only the human health risk assessment, which is carcinogenic human health risk and non-carcinogenic human health risk, right? So now let's apply this to our particular site. So what do I have here? I have a plethora of information out here, but let's not be blown away. So what are we dealing with? We are trying to identify the relevant hazards, and in this particular table, these are the various compounds that were identified from different monitoring wells in the location of, or in the vicinity of, that particular landfill, right? And obviously if you look closer or look at this data closely, you see that it's limited to the potential carcinogens, right? So here we are looking at potential carcinogens, and they come up with a ranking and indicator scores, And why do we need to come up with ranking and indicator scores, right? Because we are going to look at which particular compounds are we going to, let's say, pay more or attention to or such, right? So obviously that's going to be depend upon, let's say, factors like how toxic or how carcinogenic is the compound, let's say. Usually if it's carcinogenic, people do take that into consideration or for remedial action, let's say, right? And what's the frequency of detection, and what is the level of detection, or what is the concentration at which the compound is detected, and so on. So here I guess they have again different compounds and a few heavy metals and so on here, right? Yes, and other compounds too here, 1,2-DCA again, right? Trichlorophenol and such, chlorinated organics. So in general here we see quite a few heavy metals and then chlorinated organics, right? And then what do we see here? We see the different pathways, usually groundwater, surface water, and in the leachate they analyze the concentration, they looked at the maximum and average values for the different pathways, right? And again similarly for soil and sediments, I guess, right? And then based upon a ranking matrix, let's say, or their own weightage that they gave to different compounds, let's say, and again we are not going to go into that in great detail at this stage, they came up with indicator scores for these compounds, right? For both the maximum or the worst case scenario and the average case, and then they ranked the compounds, right? And then they ranked the compounds, one being of the greatest concern, I guess. So again that was hazard identification and then potential carcinogens. So obviously if we considered carcinogens, right, we also need to or we are also going to look at non-carcinogens or the toxic compounds. And obviously again the same case we are going to look at non-carcinogens, right? And here we have, let's say, again different compounds, and one aspect is different compounds depending upon their what do we say, mode of ingestion or exposure and level of concentration can be both can have both toxic effects and also non-carcinogenic carcinogenic effects, right? And one example is arsenic. It has both carcinogenic effects and also toxic or non-carcinogenic effects too. And again you have various other such heavy metals and so on, right? And again chlorinated organics too, I guess, right? So again what do we have? Same case, we have different pathways, right? And then they come up with the concentrations, the average and the maximum concentrations in each of these pathways. So obviously as you see, remediation and of any contaminated sites is a resource intensive job, as in right now as you see a lot of data is required, and for that obviously you need a lot of resources, right? So it's again resource intensive. So obviously we would always try to look for or try to promote, what do we say, measures that would stop such spills, right? Or so thus obviously if the relevant people who manage the landfill paid greater attention at the time of laying the landfill, and maybe if they had a what do we say, impermeable layer beneath or impermeable liner beneath the landfill and a particular leachate collection system. So this level of resources or expenditure probably would not have been required at a later stage, right? Again this is where we are. So again concentrations are looked at and different pathways are looked at, and in some of them obviously it's not detected, right? So and then based on this indicator scores, and then again we rank the different compounds, right, depending upon, let's say, various factors. And again keep in mind that various countries or various states, let's say, have their own ways at giving different weightages, right? But usually it's again, as I mentioned, the level of toxicity or the if it's a carcinogen, obviously they will consider it in general anyway, level of detection and level of frequency of occurrence, right? So again moving forth we are looking at hazard identification, right? And then let's say what else have they looked at? They looked at, let's say, the EPA toxic rating, right, based on the weight of evidence. Weight of evidence as in how do we know whether a compound is toxic or carcinogenic? We conduct tests on the laboratory animals, right, and then come up with what do we say, what's the response or the adverse effect that was noticed due to, let's say, a particular dose, as in, let's say, hair fall after, let's say, dosage of 1 milligram per kg of body weight. I guess these are very random values, but I'm just giving you the example for the purpose of visualization, I guess, right? So based on that, let's say, obviously, you will have uncertainties out there. So there are different levels of evidence out there, right, as is seen out here, right? And some might require further testing, some might what do we say, have insufficient data and so on. So again this aspect was considered. And what else have they considered for screening those relatively long list of chemicals. They looked at what's the presence, if its presence in leachate, its presence in groundwater, presence in, more importantly, the residential wells, and then the number of media that it was present in, right. So, considering these factors, they came up with a few of these compounds being chosen, let us say arsenic and so on, right. So, they did not obviously choose all the compounds, they looked at, let us say, indicator compounds, if I can call them, let us say, right. So, obviously what did they look at, let us say some of the rankings that they looked at earlier from the previous case, the EPA weight of evidence and its presence in what do we say, different, what do we say, media or pathways, and also the number of media, and they chose that. I think we have a list here. So, here we have the final indicators, right. So, based on the scoring process, they chose carcinogens and a few non-carcinogens or one non-carcinogen, right. So, this is what the study threw up, right. And then obviously what did EPA or US EPA suggest? Again, EPA is the Environmental Protection Agency, right. And so, they suggested adding a few more compounds, right, I guess. And here they have the final list of compounds that they need to consider for relevant action, I guess, right, or for risk assessment, right. And I am just giving a brief idea about how things work, right. And then obviously we need to look at exposure routes, right, and characterization of human exposure points, right. So, exposure routes as in what particular path or what pathways are leading to transport of this particular contaminant. So, what do we have here? We have groundwater, surface water and sediment, air and soil, right. And how can it go? For example, one example is that contaminated soil and waste leaching, right. So, if you have contaminated soil or the waste leaches through to the groundwater, you have contamination of the groundwater and so on. And then what next? We have the exposure point here, how are the humans being exposed or where though, right. And what is the exposure route? For example, groundwater ingestion as in they drink the water, right. Dermal as in they are going to bathe with this particular groundwater that is pumped out. So, dermal contact or contact through the skin and then adsorption through the skin, that is one point of way, right. And then inhalation, let us say if while they are let us say cooking with this particular groundwater or such or coming in contact with it. So, again you will have what do we say, the relevant compound depending upon how volatile it is, changing phase from the water to the gaseous phase, and then I can breathe the relevant compound and thus be what do we say, affected by it, right. So, in this context let us say groundwater, we looked at a few aspects, I guess, exposure point and ingestion route as in I drink the water, if I bathe it, let us say my skin comes in contact and my skin can absorb the relevant compound, and through inhalation. Again for different compounds, let us say if I take the case of skin contact or dermal contact, I guess, right. So, not all compounds will be what do we say, taken in at the same rate, right. So, obviously I am going to look at those relevant standard values too, they are relatively available, I guess. So, estimated number of people that are exposed, and is the pathway complete or are there any missing what do we say, links in the transport chain, right. So, based on this I am just trying to characterize the exposure routes, right. So, once I move on to that, obviously I need to look at what is the concentration at the receptor, right. So, earlier we looked at the concentration in the vicinity of the landfill, now I am going to look at the concentration at the receptor, right. Let us say I am the human living in the vicinity, I am the receptor, right. I am concerned about what the concentration is at my particular point of usage, not what the concentration is at the landfill. So, obviously again for the chosen compounds, arsenic, benzene and so on, right, we look at the exposure point concentration. So, obviously if you try to look at or go back to the relevant slides earlier, you see that the concentrations are either low or not detected, right. So, what does that mean? There has been some attenuation by the time, let us say, or not by the time, during the pathway, as in by the let us say the leachate reaching the groundwater and then reaching the receptor, which is the human here, right. So, obviously these concentrations at the receptor are lower compared to the concentrations at the landfill, I guess, right. Again different cases, exposure point, great level of detail, we are not going to go into that at that level of detail right now, right. So, then obviously I need to characterize the human health risk, I guess, right. So, obviously from different monitoring wells, what is the concentration for different compounds, right, representative case and conservative case. Again obviously I need to be able to estimate the daily intake that I can get based on, let us say, if it is with respect to ingestion, let us say. I know the amount of water or the average amount of water that, let us say, a human consumes. So, from that I can come up with daily intake, and based on the concentration I can come up with the actual compound that is being taken in or can be taken in by that particular human in that exposed to that particular compound, I guess, right. So, obviously, I have the slope factor here, right. This is from the standard data, and so here I calculate risk into 10 power minus 6. Usually if it is what do we say, the thresholds are either 10 power minus 4 or 10 power minus 6. So, depending on the agency, if the risk is either greater than 10 power minus 4 or 10 power minus 6, it is deemed to be high enough to be such that you need to take remedial action. So, obviously here they are choosing the threshold I believe to be 10 power minus 6, and the compounds that have relatively what do we say high what do we say risks are highlighted out here, right. Tetrachloroethylene obviously though has very high risk, right, and again I believe is it arsenic and arsenic, I guess, right. So, here after calculating the risk will give me an idea, or what will it take into account? It will take into account the concentrations that I am exposed to, let us say, the pathway, right, and here I believe what am I looking at in groundwater, right, associated with potential carcinogens in groundwater, right. So, the pathway, the type of compound, right, and the amount that I am taking in, and then it will give me a particular risk. So, as you see now, I can try to have a relative comparison, right. I can understand, let us say, which particular compound that is present in groundwater at those relevant levels, right. Obviously not all compounds are present at the same concentration. So, here we have different compounds at different concentrations, different compounds have different levels of carcinogenicity, right. So, the risk characterization takes that into account and obviously comes up with what is this now, the incremental risk, cancer risk, as in what is the additional cancer risk that ingestion of this particular groundwater would pose to that particular human, right. So, that is what we have here, and I guess this is something we are going to look at in detail during the course of our particular course, I guess, right. So, again, how do I calculate this cancer risk, I guess, or lifetime cancer risk? Obviously, we have the slope factor for that particular compound, slope factor for that particular compound into this particular, let us say, daily intake, I guess, right. As you see, the units, they cancel each other out, and that is how I come up with lifetime cancer risk, and obviously I need to sum up all these risks to understand the cumulative risk posed, I guess, right. So, again, here I am going to now look at non-carcinogens. Earlier we looked at carcinogens. We are now considering the case where groundwater again is contaminated, and I am ingesting that groundwater, and I am looking at non-carcinogens. Again, concentration, daily intake, and acceptable daily intake or reference dose, right, and then I am going to calculate the hazard index. Some is, I think, hazard quotient. How do I calculate that? It is daily intake by the reference dose or the acceptable daily intake, right. Usually the threshold is 1. If it is greater than 1, if the sum of all the hazard index is greater than 1, that means that I am taking way too much of the toxic compound, and I need to look at the relevant remedial measures. So, in general, as you see now though, most of the risks, individual risks are relatively low, but there are still, what do we say, risk posed from some particular compounds, right, that can potentially lead to considerable toxic effects, right. So, I guess I did highlight a few of those particular compounds though. Obviously, the sum will be greater than 1. So, obviously, I need to, at this stage, I can scientifically come to a conclusion that individual compounds to pose unacceptable levels of risk, as we can see in this case of ethyl hexyl thiolate, right, which is, I believe, a plasticizer, yes, right, and certainly the sum of all these risks will be greater than 1. That tells me that at least for the non-carcinogens, or from the point of view of the toxic effects of the non-carcinogens, I do need to remediate the site, right. So, again, going forth, let us say, what do we have? Potential risks associated with volatile organics in shower water, I guess, right. Again, a different kind of pathway, let us say. So, I am not going to go to that in detail. So, in different pathways though, now we see that for, I guess, benzene and chloroform and 1,2-DCA, which are relatively volatile, right. The risks in this particular case, as in shower water, relatively higher temperatures and such, are remarkably high, which probably was not the case here, as you see, in groundwater. as in for chloroform, right, in the conservative case, right, we see that the risk is around 0.09, but for chloroform, right, in the case of shower water, we see that the risk posed is remarkably high, right, or it's, I guess, incremental cancer risk. I should not compare it with here. So if I look at the cancer risk here, chloroform, that's turning out to be 69.4, okay, they are comparatively high, and it's still high or pretty high, right. This is from the cancer risk, yes, and again bath water and so on. So again, what do we have here? We are trying to analyze different pathways. So when I sum up the what do we say all the risks associated with that pathway, I will then able to understand, let us say, or come up with an idea about which pathway. Is it through bathing or through shower water contact with my skin that I am posed to or exposed to the greatest adverse effects, let us say, or potential adverse effects, or is it through the drinking water. So again, this level of risk characterization and risk assessment will help me understand those aspects now, right. So moving on, let us say, depending upon the relevant analysis we are going to do during our course, right, we are then going to come up with different alternatives, right. So here obviously we are not going to go through that in that level of detail, right. So here one aspect is doing nothing, right. Let us say if it is a remote location and the risks associated are less, that is one aspect that you can certainly choose, but that is not the case. But usually obviously for looking at, let us say, the no action alternative will let you come up with the relevant costs and risks for relative comparison, right. So that is one aspect. The other one is cap, right, a cap on the particular landfill, so that no particular so that it will limit formation of the leachate to leachate collection, groundwater pumping, and on-site treatment of leachate and groundwater. Another one is on-site pre-treatment and off-site treatment, more or less 2 and 3 are in conjunction, right. Again on-site treatment, leachate collection. So different, what do we say, as you see here, we are coming with different alternatives, more or less they are geared towards pumping the leachate out and then treating it, right. And again we are going to look at that in greater detail later on, right. But the other aspect that relatively unique is that it says that incineration on site and disposal of residue on site in a landfill or a hazardous waste landfill, and then groundwater pumping, treatment, and restoration of the site. So here on one hand you have more of the what we say the same kind of alternatives which look at more or less pumping out the groundwater, having what do we say a cap so that the landfill will not be exposed to any rainfall or such or snow in that particular area, right, and again treating the groundwater. The other one is again incineration of the relevant what do we say contaminated soil or such, let us say, and then disposal of residual on a landfill, again more costs, and again groundwater pumping and so on. So how do we go about choosing between different alternatives, let us say, right. So again more alternatives here, we are not going to go through that. Major aspects being incineration off site, I carry the contaminated soil or such off site and then incinerate it. The other one is soil flushing, let us say, or soil washing if I can call that, and the other one is in situ biodegradation, similar to what we talked about with respect to the groundwater contaminated by chromium in the Ghaziabad case, I guess. So major aspects, different what do we say combinations of such aspects are different alternatives, I guess. So how do I go about that? Obviously I need to look at various factors. So here obviously I am going to look at different cases here, as in all the alternatives are listed here 1 to 11, that is the number of alternatives that we just considered, and we are going to look at, let us say, what are the aspects involved here, right. So that we know the amount of resources that we are going to look at, or are possibly involved, and also going to look at the practicality of this particular remedial options in addressing those particular risks, I guess, right. So that is what we see here, and then again available remedial technologies, can this particular aspect meet your particular alternative and so on. So we are going to look at that. As you see, water and dust control will be met by most of the alternatives. In situ treatment, let us say, will only be met by a few alternatives and so on. Why would you consider, let us say, in situ or ex situ or off site? Because let us say transportation costs and also potential what do we say contamination of the air during excavation and transportation and such. So again we are not going to go into great detail here, but we are just trying to compare different aspects here with respect to the alternatives, right. So again, moving on, let us say implementability of screening criteria. What have they looked at? Effective performance of the alternative expected, how effective is it? So looks like 1 is no and most of the others are yes, and 10 and 11 no. Is the alternative reliable? Obviously, something that you put in should be reliable in the long term. So in that context, again they looked at different, what do we say, alternatives, the 1 to 11 that we looked at. Is it practically implementable depending upon the site conditions out there? Is it safe to implement? Yes, as in during the course of remediation should not what we say, lead to further contamination of the site, right. So based on these aspects, obviously all the 11 alternatives are again considered, right. And then obviously the major aspect is the public health screening criteria. Alternative minimize or prevent exposure to contaminated groundwater, surface water and so on. So they look at or analyze different particular alternatives, and again different public health screening criteria. So obviously what do we need to balance? We need to balance, let us say, the effectiveness of remediation, which is what we see here in the public health screening criteria, and also the practical aspects, right. So those are aspects that are looked at. But during our course though, we are going to look at the technical aspects, as in trying to understand, let us say, can a particular alternative meet the requirements, or is it, how effective is it in reaching your remediation goal, right. So that is something that we are going to look at, let us say. So moving on, let us say again, now we have with respect to the environment, right. Earlier we had it with respect to the human health, and now here we have the screening criteria with respect to the environment. Again more such criteria and so on. For example, improve the environmental quality of groundwater, surface and so on. I am going to skip this. And then what do we come up with? So passes health screening, passes environmental screening, and passes implementability screening. Again practical aspects and human health risk assessment aspects, or human health or adverse human health aspects, and then environmental screening aspects. So based on that, they come up with, let us say, a few particular alternatives as being considered, and a few alternatives are screened out at this stage, right, at this preliminary stage. So what next? Obviously the resources, right, is something that you need to look at. And here let us say they have based upon the 7 alternatives that are further chosen, let us say they look at capital costs, annual operation and maintenance costs, and present worth. That is something you are not going to look at. So obviously capital costs are relatively comparable, right, for most of these particular alternatives as you see. But if you are coming to or operation and maintenance costs, as you see, having the cap and collecting the leachate and then on-site treatment of the leachate or the groundwater, the costs are relatively low compared to, let us say, on-site incineration or biodegradation, right. So annual costs here are almost, let us say, 10 times higher with respect to 6 and 7 alternatives compared to the alternatives 4 and 5, right. So here is where, let us say, the management needs to take a decision, right. Here you have costs that are exponentially high, 10 times high is almost infeasibly high, right. But obviously here we have relatively less invasive techniques in situ biodegradation, I guess, right. So here they are going to now take a decision based on the relevant effectiveness in addressing the human health risk as concerns, and then the cost, and go forth with choosing an alternative. And to my knowledge, they chose number 5, right. They chose number 5, as in they are going to put a cap over the landfill, and then they are going to extract the leachate based upon, what do we say, strategic placement of these extraction wells. As you remember, we had the landfill in this shape, I believe, and we had extraction wells out here, right, and we also had monitoring wells out here, and I am pretty sure near the human receptors too, and so on. Extraction wells, and then pumping it out and then treating it, and then sending this particular treated effluent to the municipal or municipal waste treatment plant again. So they are treating it twice more or less, but pre-treatment for the particular heavy metals and the chlorinated solvents. And during this course, they are going to, what do we say, spend money obviously on providing safe or potable drinking water to the relevant population out there, right. So this is how we go about, let us say, looking at different aspects when it comes to contaminated sites or remediation of contaminated sites. So in this course, as I mentioned, we are going to look at some aspects in greater detail. So let us look at what they are. So week 1, or maybe during the final week, let us say we are going to look at what are the different laws and regulations in this context, let us say in our context or the Indian context. Maybe we will spend some time on comparing how we fare with respect to the level of regulation that the other, or let us say the western countries have. So, we are going to look at our particular case mostly. I mean, obviously we need to know what are the legal safeguards that are in place, right. So, that is something that we are going to spend some time with, and then again the relevant aspects with respect to the history primarily. And then in this context, obviously this is a major aspect we are going to discuss, as in definition of the hazardous waste. I mean, what is hazardous, right? How do you classify a compound as hazardous, right? So, that is something that you need to look at. Obviously, you have municipal waste and then you have the hazardous waste, right? This is a category by itself, that is something we are going to discuss, right? Again, then we are going to move on to risk assessment, right, as an introductory aspects, and then human health risk assessment. We looked at these aspects in great detail, and ecological risk assessment, and based on the risk that you calculate, you need to take the corrective action, right. So, that is something that again we are going to look at, I guess. So, I guess due to lack of time, I am going to wrap up here, and I guess I will start looking at the relevant aspects from the next session, while also finishing up the relevant outline, right. So, I guess with that I bid adieu and thank you.